Hey everyone, so today we are working on concavity again, but we're really going to focus on the graphs. Looking at the graphs and kind of evaluating what do we know about the original function based on the graph. Alright, so I want you to pause. I want you to find the third derivative of this guy. Alright, so whenever I'm asked to find a third derivative, what I usually will do is I'll write it with fractional exponents and negative exponents because I know this is going to get complicated. So 1/6 x to the 1/2, 2x to the negative 1/2, 8x to the negative 1, and then 3x to the negative 3. Now, if I just was asked for the first derivative, I wouldn't do it this way. But because they're asking for the third derivative, I know this is going to get a little wonky. So first derivative, multiply my exponent by my coefficient, subtract 1. 2 times negative 1/2 is negative 1. Subtract 1, I get negative 3 over 2. Negative 8 times negative 1 is positive 8. Minus 1 is minus 2. And then multiply minus 1 becomes minus 4. So then second derivative, repeat the process. Multiply, negative 1 over 24. Subtract 1. Negative 1 times 3 over 2, negative 3 over 2 is positive 3 over 2. Subtract 1. 16, negative 3, and 36, x to the negative 5. Then we're going to do it one last time. What's that? 3 over 48. It's 1 over 16. X to the negative 5 over 2. Minus 15 over 4. X to the negative 7 over 2. Plus 48. X to the negative 4th. And then minus 180. X to the negative 6th. And then if you want to rewrite it, I usually do, because they gave it to me as roots, I usually write it in the way that they gave it to me. So this is 1 over 16, and then the square root of x to the 5th, minus 15 over 4, the square root of x to the 7th, 48 over x to the 4th, and minus 180 over x to the 6th. There's no real rule there. That's just how I always do it. Okay, so this is, I put up there, page 326. We're going to go through numbers 63 to 66. So if you want to pause and just go and do those in your textbook and come back, or you can do them as I do them, go for it. But I want you to try these on your own. So the left graph is f prime. The right graph is f double prime. So we're going to be able to answer all these questions about f. Notice every question is about f. That's important. Pay attention to what they're asking about. And yeah, so go through answer A through H. So critical numbers are where f prime equals 0. So that's negative 2, 0, and 2. Right, f prime equals 0 is critical numbers. Where is this increasing? Increasing is where f prime is greater than 0. Right, this is f prime equals 0. Greater than 0 would be right there, negative square root of 3 to 0. And then root 3 to infinity. Ugh. And then decreasing, where is the graph below the x-axis? That's negative infinity to negative root 3. And then 0 to root 3. Does f have a local minimum? So local minimum is where the derivative changes from negative to positive, right? So a minimum is the slope is negative and then the slope is positive. So negative to positive would be here and here. So negative root 3 and root 3. Max is where the slope goes from positive to negative. So that is x equals 0. Concave up, now we're on the other graph. That's f double prime is greater than 0, so above the x-axis. That is negative infinity to negative 1, right? This is where the graph is above the x-axis, and then 1 to infinity. Concave down, the second derivative is less than 0, below the x-axis. Negative 1 to 1. And then inflection points, where does this graph change from positive to negative or negative to positive? So that is our negative 1 and 1. All right, same problem, just different graphs go through. Critical numbers are where f prime equals 0, so that is 1. Increasing, f prime is greater than 0, 1 to infinity. Decreasing, f prime is less than 0, negative infinity to 1. Local minimum changes from negative to positive, so that's x equals 1. There is no max. It does not change from positive to negative anywhere, so that's NA. Concave up, where is f double prime greater than 0? That's all real numbers. You can put negative infinity to 0 and then 0 to infinity. Some books will make you do that, not include the 0. This is never concave down, and it has no inflection points because it never changes concavity. All right, 65. Pause the video, and try this on your own. So critical numbers, where is f prime equal to 0? So that is at 0 and 1. X equals 0, x equals 1. F increasing, that's f prime greater than 1, f prime above the x-axis, negative infinity to 0, 1 to infinity. Decreasing, f prime less than 0, so f prime is below the x-axis, 0 to 1. Does f have a local min? So a local min is a negative slope to a positive slope. So f prime changes from negative to positive at x equals 1, right? It's below the x-axis, and then it's above the x-axis. The local maximum is at 0. That's positive to negative, right? Slope is plus, then the slope is minus. Concave up, so that's looking at f double prime. F double prime is greater than 0 from the cubed root of 1/4 to infinity. Concave down, negative infinity to the cubed root of 1/4. That's x double prime below the x-axis, and then that x equals the cubed root of 1/4 is your inflection point, since that's where f double prime equals 0 and f double prime changes from negative to positive. All right, next one. Let's see, determine the critical numbers. Negative 1, 0, 0, and 1. However, that 0 isn't going to be anything, right? It doesn't change sign. It doesn't go from negative to positive or positive to negative. So that 0 isn't going to be anything. Increasing, negative infinity to negative 1, 1 to infinity. Decreasing, negative 1 to 1. Local min is negative to positive, so that's x equals 1. Max is positive to negative, so that's negative 1. Concave up, that is where f double prime is greater than 0. So negative root 2 over 2 to 0, and then root 2 over 2 to infinity. Concave down, f double prime below, and then 0 to root 2 over 2. Inflection points are plus or minus root 2 over 2 and 0. So where does it change? Where does f double prime change from positive to negative? Try not to use the it word. Okay, so now this is on the same page in the book, but we're going to go through numbers 75 through 80. So this is sketching. Normally if we were in class, I'd give out the whiteboards, but we're going to have to do this without. So I want you to just try, based on the information, to draw the picture, right? So concave up, remember, looks like this, concave down. But then if we're talking concave up increasing, concave up decreasing, concave down increasing, concave down decreasing. So we're kind of using those ideas of increasing, decreasing to draw this picture. Also, a lot of these, there's a point that's not differentiable. It's really, really common. So they gave a 0, 1. So concave up this thing is always concave up. So it's always cupped up. It's increasing from negative infinity to 0. So concave up and increasing. And then decreasing concave up. So decreasing concave up is this one. So it looks kind of like that bird, picture of a bird or something. Which one is that? That's like x to the, I can't remember. X to the 2/3 maybe? No, I don't remember. All right, next one. Concave up, from negative infinity, so that's cupped up and then cupped down. 0, 1. So concave up and decreasing. Concave up and decreasing is this guy. So that's this. And then the second half, concave down and increasing. That's this guy. So again, there's not a point of differentiability, but that's okay. All right, so concave up increasing, concave up decreasing, concave down increasing, concave down decreasing. All right, so now we have 2 points this time. So this one's a little harder. So we have 0, 1 and 1, 2. All right, so I got 2 points. So it's concave down from negative infinity to 1. But it's decreasing negative infinity to 0. So we've got decreasing concave down, decreasing concave down, like that. But then from 0 to 1, we have still concave down, but it's increasing. So concave down, increasing, so it's going to do that. And then we go to increasing concave up. So that's where we go up. Next one, again, same points. Concave down, but this thing is always increasing. So we are concave down to 0, concave down and increasing. That is that. And then we're still increasing, but now we're concave up. It's kind of like an x cubed, right? X cubed plus 1. All right, so now this is the same exact thing, but they're just giving you the information in a different way. What I usually do is I actually write out the words. I think it's easier. So f prime greater than 0, so that's increasing from x is less than 0, so negative infinity to 0. Decreasing from 0 to infinity. F double prime is greater than 0, that's concave up, negative infinity to 0. And then it says concave up again, right? Look, it's greater than again. So this thing is always concave up, right? So this thing is always concave up. I got my 0, 1, but it goes from increasing to decreasing. So increasing concave up, decreasing concave up. Alrighty. I think this is the last drawing problem. So we have 0, 1 again. F double prime equals 0. F prime equals 0. F double prime is greater than 0. That's concave up. And then over here, it's concave up. So all they're really saying is this is concave up, the derivative is 0 at 0, and the second derivative is 0 at 0. So if we're always concave up, I just think of it like a parabola. The derivative here is 0, the second derivative is 0. That's it. All right, last one. Which of the following is true? So when it says f is increasing, f is decreasing, they mean all everywhere, right? F is increasing everywhere, f is decreasing everywhere, f is discontinuous at 0, etc. All right, so try to figure this one out. Pause the video, try it on your own. So increasing, decreasing is first derivative, so that is 2x minus 2e to the negative 2x. So if I set that equal to 0, so x equals 0 would be my, this thing, if I plug in 0, no, I don't get 0. All right, this was a little hard. So now I'm just going to think about what's happening with a positive. If I plug in a really big positive number, I get something minus, whoops, that becomes a plus. I forgot to change it. The limit as x approaches infinity is just positive infinity, right? As if I plug in a positive, I get a positive. If I plug in a negative, I get a negative. I get a negative. So it seems like it's increasing and decreasing over the whole thing. So I'm not really sure what I'm doing. So let's try the second derivative, see what happens there. 2 plus 4e to negative 2x. All right, so this is concavity. Where is this thing positive? If I plug in positive numbers, I get a positive. If I plug in negative numbers, what do I get? I still get a positive, because remember, e is negative. So this thing is always greater than 0. So this graph is always concave up. So for the first half, I was kind of just talking my way through it. If you don't know what you're doing, if you get stuck, well, go on and try something else. And that really helps you get to the answer. All right, and there is your homework. Have a great winter break. Hope you get presents if you celebrate. See you later.